This is Unit 5, Day 3. And today we're starting with operations with radicals. Examples 10 and 11 you're going to see undo each other. So for example, opposite operations are adding and subtracting, because to undo addition, you subtract. And opposite operations are multiplying and dividing. So if you wanted to undo multiplication, you divide, and vice versa. If you wanted to undo division, you multiply. So square and square root are opposite operations and undo each other. So this is pretty basic, pretty easy. So you're just going to go through and you could use your calculator for these, but you shouldn't need. These are pretty basic. Okay, so there's those. Now, the opposite operation of those, you're going to see a little pattern. Now, if you look at these down here, this is going to be 5. So look, 5 squared, square root of 25 is 5. This is 10. Again, you should notice something. This is square root of negative 16. Not real. Okay, that's going to be coming up soon in this unit that we're going to learn about imaginary numbers. Okay, this one is 2, this one is 3, and this one is negative 4. Don't forget, negative 4 times negative 4 times a negative 4 would be negative 64. So that's why that one actually works right there. Okay. Alright, this next little blurb in the box is super important. The square root, okay, so this right here is called the index. So square roots have index of 2, but as you can see, a normal square root, we don't write that the index is 2. You just kind of have to know that that's how we write it, okay? Any other index greater than 2, it has to be written. So the cubed root, or if I wanted to take the 4th root, okay, so you could see the word here, index or root, okay? So this one, the root's 3, but again, your normal square root has an index of 2. We just don't normally write it. Okay, so is square root of 50 considered simplified? Simplest radical form, explain. I'm going to say no, okay? Explain, because there still is a perfect square factor that can be divided out, or you can say is remaining in 50. So if there's a factor, meaning two numbers that multiply together to give you that number, and one is still a perfect square, then it is not fully simplified. Okay. Simplify each of the following. Put the following in simplest radical form. So back in algebra, you'd say what two numbers multiply together to give you 50, but you want the largest perfect square that's going to give you that. So this one is 5 radical 2. Okay, largest perfect square to give you 18 would be 9. 9 times 2 is 18. That's 3 radical 2. Okay, this one's a little different. You have a coefficient that's going to come along for the ride, and that reduces to radical 4 times radical 2 would be radical 8. It's 2 times 2 radical 2, so that becomes 4 radical 2. Okay, now simplify example 14. Simplify the following. Remember, you can only combine like terms. So you need to get common radicals. So you cannot add and subtract radicals unless they have a matching radical. Okay, so we just simplified radical 50 up here in example 13 part A. That is 5 radical 2. The square root of 18 simplifies to 3 radical 2. And then 2 radical 8 simplifies to 4 radical 2. So now they have a common radical of radical 2, so you keep it. So radical 2 stays. Do not go 2 plus 2 plus 2 and give me radical 6. That stays. Then you're just going to take your coefficients. You have 5 plus 3 plus 4. So 5 plus 3 is 8 plus 4 is 12. So my answer is 12 radical 2. Alright, so the little rule box here is basically saying if you have two separate radicals that are being multiplied, you can smush them together underneath 1. Okay, if you have two separate radicals that are being divided, you could put them under one big one. Okay, so for example, if you look at example A here in part 15, example 15, you could separate that. So think of that as square root of 1 over square root of 4. Okay, and then square root of 9 over square root of 4. So that first part simplifies to 1/2 because the square root of 1 is 1, the square root of 4 is 2. And then this part simplifies to 3/2. Okay, now, oops, that's a minus sign. I have to break down radical 45. Radical 45 reduces to 9 times 5, which is going to be 3 radical 5. So right now I can combine like terms here. 1/2 plus 3/2 is 4/2, but 4 divided by 2 is 2. So my answer simplifies to 2 minus 3 radical 5. Now I cannot combine these because one has a radical 5 and one does not. So you're done. Okay, now be very careful with example part B here and part D, because now the index, okay, is the cubed root. So in your head, I would list the perfect cubes up top here. 1 cubed is 1, or 1 times 1 is 1. 2 times 2 times 2, or 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125, and that's kind of where I stop and I go to the calc if I need to. Okay? So now, you could see that 40 is not a perfect cube up here on my list. So I have to break this down. So I'm going to say, what two numbers, don't forget to write the index of 3, what two numbers multiply together to give me 40, but I want one of them on my perfect cube list. Well, 40 falls right here, so you know it has to be 27 or 8. But 27 does not go into 40 nicely, but I know 8 does. 8 times 5 is 40, but I like the cubed root of 8 because the cubed root of 8 is 2. Another way to remember it is sitting in the second spot, and I know that 2 times 2 times 2 is 8. So I get 2 cubed root of 5. Now, cubed root of 5, you can't break 5 down with anything except for 1, and you end up back. So that one just gets carried down as well. So I have 2 cubed root of 5 plus another 2 cubed root of 5. So keep and carry the cubed root of 5. You do not add them and tell me it's the cubed root of 10. Okay, that is the common radical. And then you're just going to take the coefficients out front. And you have 2 plus 2, and that is 4. So I get 4 cubed root of 5. Part C. I have 2 times 3. 3 came from the square root of 9. And then I have to break down a to the 5th is a to the 4th times a to the 1. Because 4 times 1, you add exponents when you multiply, is 5. And remember, guys, when you have an index of 2 there, it's just saying what times itself twice is a to the 4th. A little shortcut, you could take 4 and you divide it by 2, and you get 2, so that reduces to a squared, and then you're still left with 1 underneath. Okay? Now I'm going to combine this and this, and my answer is going to be 6a, and then I have, 6a squared, sorry about that, and then you have square root of a. So there's my answer for part C. Alright, part D, a little different here. So now I'm on cubed roots. So the cubed root of 16 is going to be 8 times 2. 8 times 2 is 16, but the cubed root of 8 is 2, so I get 2 cubed root of 2. Okay? Now, cubed root of 5, a to the 5th. 5 is not divisible by 3, so we have to rewrite it into things that are divisible by 3. So the closest power to 5 that is divisible by 3 is 3. But because it has to add up and equal 5, it would be 3 and 2. So 3 plus this 2 gives me my 5. Now look right here. Remember, the shortcut is 3 divided by 3. That's going to be a, or power of 1. And I have cubed root of a squared. The last step is to take everything on the outside. So I have 2 and I have an a. So that gets written as 2a. And then underneath the cubed root, I have a 2 and an a squared, so that gets put together underneath. Don't forget to write the index on that, or the root. Alright, so radical 15 times radical 15 is what it means to be squared. Cubed means you have 3 of them. So because it's square root, index of 2, okay, that just simply means that radical 15 times radical 15, the shortcut is 15. If you have 3 of the same thing that is a cubed root, that number is just 4. Okay, plus, and then I have 4 radical 7 times 4 radical 7. 4 times 4 is 16, and then I have 16, so that gives me 16, right there. And then radical 7 times radical 7 gives me a 7, so I have to do 16 times 7, and 16 times 7 is 112. So I have 15 minus 4 plus 112. If I use my calculator, that's 123. Okay, part F, we're almost done here. Part F, you have to distribute, so hand them out through multiplication. So radical 2 times radical 3 is radical 6, and then radical 2 times radical 2 is just a 2, but because this is positive and that's negative, that's minus 2. Another way, we usually write the number first that has no radical, so that's the same thing as saying negative 2 plus radical 6. FOIL, first term, so I have 3 times 5, I get 15. My outers, I have 3 times 8 radical 2 is just 3 radical 2. Inners, be careful of my signs. I have a negative, radical 2 times 5 is minus 5 radical 2. And then last but not least, I have radical 2 times radical 2 is just a 2, but I have a negative times a positive, so it's minus 2. Now I can combine like terms. 15 minus 2 is 13. And now I have 3 radical 2 minus 5 radical 2. Remember, you keep and carry the radical 2, but 3 take away 5 is minus 2. So it's 13 minus 2 radical 2. Alright, so foiling this, I have to write it out twice. My first terms, I get 25. Outers, I get 5 radical 6. Inners, I get 5 radical 6. And my last, radical 6 times radical 6 is just a 6. So 25 plus 6 is going to give me 31. And 5 radical 6 plus 5 radical 6 is 10 radical 6. Don't forget to keep and carry radical 6. It does not change. You don't add them. Okay?